But kicking off things here in the main stage is our first AI in Action enterprise story. And I'm pleased to say we're joined by Xian-Sheng, the Vice President and Distinguished Engineer of the Alibaba Group, who's going to be discussing with us now overcoming economic disruption and how to use AI to turn immediate response into future advantage. Please welcome Xian-Sheng to World Summit AI. Thank you.
Thanks, the chair, for the introduction. Good morning, everyone. I'm going to talk about how artificial intelligence can be realized in large scale in the real world to help people and to help the economy. Shall we, the slides works? Okay, good. Let me tell a short story first. I have been working on AI for over 20 years, from technology innovation, product making, and application landing. Here shows some of the projects my team and I had been working on, including Windows, Bing, Alibaba Taobao, Alibaba Smart City, Healthcare, and the Industry Vision, and so on. At the same time, I also mentor quite a few students to learn AI and then innovate new AI technologies. I'm quite happy that I can do AI myself and also can help people to learn AI and then do AI. However, there's one person who is not happy about that. That's my wife. She often says, "Why don't you teach your son to learn computer vision and artificial intelligence?" After hearing it many times, I think it is reasonable I should let my son learn AI in advance, even though he is only 13 years old now. So I start to convince my son to learn AI. However, I found he was much more interested in computer games and the debates than AI. One day, I told him again, AI is going to change the world. It's going to be very powerful. You have to learn AI as soon as possible. Today, I can start to teach you AI, and soon your computer will be able to recognize cats and dogs. My son looked at me for a while and replied, "Dad, I could recognize cats and dogs when I was 1 year old. That's not powerful at all. And if AI can do everything, why do I need to study now? When I grow up, let AI do everything for me." Looks like my son's question looks like a nonsense, but actually there are about two important things about AI. That's the core value of AI and future impact of AI to human being in the long term. I often categorize the core value of AI into three stages. The first stage, icing on the cake. That is, you are offering something nice to have, but it doesn't matter too much if we don't have it. The second stage, offering fuel in snowy weather. That means you are offering a must-have feature or function. Without that, things can be very difficult, either taking too long time or cost too much money or labor or very dangerous, etc. The value created here can be called irreplaceable values. The third stage, creating something new and big. This stage is something desirable, yet very difficult to reach. Maybe today's cell phone, the big screen is a very good example. You know, cell phone originally were for voice communication, but currently it is much more than that. When we have big screen, it's changed a lot. It's something created and have big influence to people's lives and the economy. Of course, I'm not saying that we shouldn't do anything related to icing on the cake, but we may want to consider the cost of it. For example, if we use 1,000 people to do icing on the cake thing, and for over years, that's not cost effective at all. Mostly, our goal is the second stage, and keep an eye open for the third one. In the past 5 years, very lucky that I have worked on quite a few AI projects that fits the definition of the second stage, and some are even close to the third one. Let me introduce this to see how AI technology can be realized in the real world with must-have values. The first example is the Smart City, Alibaba's Smart City. It is a very complex and big AI system that improves the efficiency of urban planning and operation, allowing urban residents to have a higher standard of living. For example, the detection and optimization of traffic flow can quickly locate traffic incidents, quickly clear traffic congestions, and even reduce the frequency of congestion and accident through traffic prediction and intervention. Three-dimensional modeling can also be used here to restore the changing patterns of urban traffic in time and space, so as to find a more in-depth method to optimize traffic. Of course, it will also give us a more intuitive way to display the overall picture of the city's traffic. The second example I'd like to share is the flaw detection in photovoltaic cell sheets. Usually, we need a real person to check it carefully to confirm whether there's a flaw, there's a defect, which is very time-consuming and also cumbersome. Now we can do it through AI and do it better than humans. The usual accuracy rate for human is something like 93 to 96%, and AI can reach 98%. Human need 2 seconds to complete one, while AI only takes 1/10 of the time. Human can identify 4 types of defects, and the machine can identify 20 defects. Here's another example of computer vision application in manufacturing industry for textile inspection. On the left side is the manual operation. On the right is the machine. And the accuracy of the machine achieves 99.8%. Visual intelligence can also be used in the steel industry, scrap grading, and deduction. Manual grading of scrap steel is a very dangerous job, and the grading varies from person to person. The video, I'm not sure the video is playing or not. It seems simple, but this is a problem that the steel industry has not solved well for a long time. Now, with the computer vision system, the scrap grading and deduction accuracy rate achieves 95 and 90% respectively, which is surpass skilled workers. In the field of intelligent design, maybe next slide. Let me try it. Through, yes, here we go. Intelligence generation technology here can be used to generate advertising images, or sometimes we call the banners, automatically from graphical and textual materials. An ordinary designer also needs probably half an hour or even 2 hours to complete one banner. But the machine produces 8,000 pieces in 1 second at a level equivalent to that of a graduated designer. In the medical and health field, through visual intelligence, we can reconstruct more complete and accurate heart vessels based on the CTA images, and discover small lesions in the vessels, which is very important. In orthopedics, AI technology can automatically and accurately measure hips and knees, which facilitates the implementation of a surgery. We also used a similar technology to quickly and accurately diagnose COVID-19 infection. You know, when a new disease starts to spread, fast and accurate testing is very important. Typically, we need some time to get the test kit ready, especially for a high throughput solution. Well, if we use a CT scan image to diagnose the disease, we only need algorithms or service to recognize the new thing, because we already have CT machines, we already have CT scan images for the suspicious cases. So the technology here is to use the latest visual AI technology, as shown in this short video clip, to automatically determine whether the case is a COVID-19 infection or a common infection by other types of viruses or germs. The accuracy can be as high as 98%, and it only takes 2 seconds. This technology has been used in more than 600 hospitals in China and a few hospitals outside of China. Because of the important contribution of this technology in the fight against the epidemic, its first code snippet was collected by the National Museum of China. Based on numerous practical examples, we have summarized the key vectors that makes AI play an irreplaceable role in the real world. Yes, this is go deep into industry. We need to go deep into industry's data, scenarios, and core issues and create in-depth innovations to generate irreplaceable value. The core reason here is that on the one hand, real-world problems are very complicated. On the other hand, although we have a general computing technology today, but we don't have general AI technology yet. However, can we realize AI on a large scale through going deep into industry? In fact, there are many industries, and the various industries need to solve many different problems. We don't have so many AI experts to solve them one by one. And most of the AI experts do not understand the industry, actually. It may take a very long time for AI experts to go deep into these industries one by one. Thus, this may not be the right way to scalealize, to realize AI in the real world in large scale. So to solve this problem, we should analyze the three stages of this AI peak. And you know that AI has experienced three ups and two downs, and is currently in the third up. And this third up can also be divided into three stages. In the first stage, from around 2012, deep learning and other technologies have made AI take a big step forward. At that time, we had a very optimistic expectation for the future of AI. That is, no industry, no AI, which means no industry will not be transformed by AI. When AI practitioners began to actually develop practical AI technology, they found they need to go deep into industry to have the real landing of AI. This is the second stage. I also call it no industry, no AI, but it means if you don't go deep into industry, there will be no actual AI landing. Many of the examples we just introduced are basically at this stage. The characteristics of this stage is that in most cases, AI experts are in the driver position to develop and to land the AI technology. This approach has achieved a very good result, but as we mentioned earlier, it is difficult to achieve large scale. Now, we can also see some signs of the third stage. At the third stage, the industry will be more involved in the improvement or transformation led by AI, and even play a leading role. You can guess what this stage is called. Yes, I still call it no industry, no AI, but the meaning has changed again. Without the deep participation of the industry, there will be no AI blossoming everywhere. This stage is not to reduce the role of AI practitioners. On the contrary, it puts forward higher requirement for AI people. Because if industry experts are to participate in the innovation and the transformation process driven by AI, it is necessary to develop more powerful, more convenient, and easier to use AI tools, platforms, and basic algorithm models. But what kind of tools or platforms are we going to provide? Then the AI can be able to rapidly scale up in various industries. Before talking about this, let's take a look at the technology stack of AI. The bottom layer is the hardware, and then the cloud platform, which can be a public cloud or private cloud or even an all-in-one machine. And the computing platform, such as batch computing or stream computing. These are all infrastructures related to general purpose computing. On top of it is the research and the development platform of AI, such as large-scale model training. The next two layers are the AI algorithms and the AI platform on which the AI algorithms runs. Together, these two layers, we call it AI central platform. The platform in this layer actually is different from the R&D platform below. The R&D platform is relatively general, while the production service platform here usually industry related. Another difference is that the R&D platform is for AI researchers, while the AI production service platform can be used by AI researchers, software engineers, and industry experts. To scale up AI, the most important tools are actually about these two layers. That is the central AI platform. On top of this are the industry engines and the industry application. Now let me introduce what are these kind of AI central platform looks like. The first one in the smart city project. In addition to solving the specific problems of urban operation, we also platform our AI capabilities to empower more companies and developers to build smart city together. From bottom to up, the platform has a few cloud components and then the core AI platform part, including data service, computing service, algorithm service, search service, and the task scheduling. Above it, we have online learning engine, causal inference engine, and the simulation engine. And then above it, it is the application. When we have this platform, the efficiency of AI R&D, as well as the development of AI-based application can be much higher. For example, with this platform, it is much easier for us to develop technology for vehicle road coordination. Based on this platform, the simulation of urban traffic can also be developed more quickly, such as the simulation and the prediction of people flow in stadiums and the surrounding areas, so as to improve the safety in large-scale events. Another example of AI central platform is the industrial vision platform. We have introduced a few practical examples of industrial vision before, but there are many industry scenes and they are typically very different. Therefore, we have built a platform to allow producing AI capability for, sorry, each of the different, to produce AI capability of each problems. So this allow ordinary software engineers, not AI algorithms engineers, to produce AI capabilities to solve various industry vision problems through this platform. Another example of using the industrial vision platform is authenticity identification of liquor. Through our platform, software engineer can produce complex identification techniques. As long as some data is collected, the system will automatically select, train, and deploy models to generate services that can be used directly. The third example is the central AI platform. The third central AI platform example is the Visual AI Open Platform, which consists of hundreds of visual AI APIs to empower developers to innovate in their own areas. For example, with these APIs, we can quickly do commercial valuation and matching of open areas for shopping malls. And with this, we can also quickly build apps to help blind people recognize 80% of the information. And let me summarize what we have talked. The key of realizing AI in the real world is to go deep into industry and to look for irreplaceable values. AI can not only improve, but also can change. And the AI central platform is an efficient way to scalealize AI and at the same time to democratize AI. But this is not the end of the journey. In the future, to allow AI to have a long-term vitality and to solve more problems, we also need to transform AI from a platform into a self-evolving system, as shown in this figure. But we don't have time to talk about this today. Hope we have opportunity to discuss this in the future.